In this video, I'm going to show how to figure out what the cardinalities are for the different regions in a Venn diagram, given an assortment of information about the intersections and unions of the sets. So here we have an example. They give us all this information, and sometimes it can be overwhelming to digest what you're supposed to do with it, or even where to start. And so here, first of all, it's important to note that there's 3 sets, so that means you need a 3-set Venn diagram. Other than that, when I start digesting this information, I'm always interested in, if at all possible, I want to figure out what the middle of the Venn diagram is first, and kind of work out from there. They rarely give you the information when they list out all these intersections and unions in the order you need it. So the middle of the Venn diagram is the intersection of all the sets. Let me take a second to label my set. So that we're going to call that one A, we're going to call this one B, and we'll call this one C. And so the middle would be the intersection of A, B, and C. So that's going to correspond to this statement here in the information we're given. Usually in the information we're given, they will tell us the intersection of all the sets together. The rest of it gets disguised, but that middle is usually stated outright, but you have to find it in the listed information. So I'm going to go ahead and label my middle intersection of all sets as 14. Now once I start from there, then I want to work out kind of in a circular manner. So the next thing I could do would be this one, which would be the intersection of A and C, or I could also start with the intersection of A and B, go into that, or I could look for the intersection of C and B. Those are basically the next 3 that I want to figure out. So when I look at the information they gave me, what I'm interested in is, did they give me the intersection of any 2 sets? And so I just start reading through, and the first time I see something like that is here. The intersection of A and B the cardinality of the intersection of A and B equals 33. So on my Venn diagram, that corresponds to that blue area there. And it says that the cardinality there is 33. What I don't want to do is to say that this region is 33. That's not 33. The entire blue region is 33. So that smaller region is going to be 33 minus what we've already accounted for in the overlap of all 3 sets. In other words, that region will be 33 minus 14, which gives us a 19 for that region. So once I got that one taken care of, what I want to do is go back to my information and start scanning for another intersection of 2. It may not be there, but I'm hoping it is. So I scan along, and the next time I see an intersection of 2 sets is this one here. And that's the cardinality of A intersection C is 20. That corresponds to this area here. And again, one of the easy mistakes that people make a lot of times is they'll say this area is 20, but that is not correct. That area is 20 minus the 14 we've already accounted for. And so that's going to give us a 6. So what you might be starting to see is they're going to give us very few of the numbers that we actually need to write in our regions. Usually, the only number they give us to write in our region is the intersection of all 3 sets. The other ones we usually have to figure out by eliminating what we already know. Alright, so now I figured out the intersection of 2 sets for 2 of them. I have one more I need to figure out, and that's this here, the intersection of C and B. Now with the intersection of C and B, as I scan through my information there, it's going to be this next one right here. They have it listed as B and C because of an obsession with being alphabetical. But same idea, right? So what that is, they're saying that the cardinality of B intersection C is 24. So what I want to do is take 24 minus 14. and that's going to equal 10 for that region. So moving along, what we still need to figure out are these regions here that aren't a part of intersections. So basically this little area here, which now looks like a sunrise because I highlighted it in yellow, is everything that's in A that's not also in another set. Okay? And then similarly, this region for C is everything that's in C that's not also in another set. And lastly, B, this is everything that's in B that's not also in another set. Now, how you have to figure these regions out is not consistent. It's going to depend on the type of information they've given us. So we just kind of have to dig into it. So I'm going to start with A and figure out what else do I know about A. So I'm going to go back to my information, and the first thing I see is I know that the cardinality of A altogether is 54. Now that is not what I want to put in this region, because that is everything for A. That includes the 6 I came up with here, the 19 I came up with here, and the 14 I came up with here. So what I need to do is take my 54 and subtract off the A regions that I've already found the cardinality for. In other words, I need to take 54 minus 6 minus 14 minus 19. Notice I'm not using any of these numbers. I'm only using the number of the cardinality for that region that I've previously determined. And this is why it's necessary to work inside out on these Venn diagrams, because I need those inside numbers to figure out this outside number now. Doing the math on that gives me 15 for this sunshine region. Alright, now I want to move on and see if I can figure out what's going on with the rest of set C. So I look through all this gobbledygook of information they've given me, and reading through that, I'm looking for something that tells me something specific about C. So here's where I found that. They give me the cardinality of C. So doing this is going to be like what we did with that other region for A. So we're going to take that 48 and subtract off all the regions of C that we already know. In other words, we're going to take 48 minus 6 minus 14 minus 10, and that gives us 18. Alright, now we have this region of B that's not in any other set, and this is going to definitely be our hardest one. And the reason why is because they didn't tell us how many elements are in B. As we scan through our information here, we don't have the cardinality of B anywhere. So we're going to have to figure out another way to figure out how many elements are in that region. So just as kind of a strategy on this, if you look through, there's basically two pieces of information we haven't used yet. We have not used the A union B, and we've not used the A complement B. And so, you know, just strategically speaking, probably one of those is the one we're going to use. The one we do need is the A union B. And this other one, the B complement, will come into play to figure out the universe that's outside of A, B, and C. So for A union B, that means the set that's all of A and all of B. The reason why we can use that is we have values for every region that's in that union set except for the one we need. So what we need to do is take all of those values and subtract them from the total that we know up here. In other words, we're going to take the 77 minus the 15 minus the 6 minus the 14 minus the 19 and minus the 10. And when we do the math on that, what we'll get is 13. I had to take my green wall down there because it was going to take up too much space. but basically it's 13 for that region. So that gives us that. Now what we need, which my diagram doesn't show well, is we need to figure out how many are in the universe that's not in set A, B, or C. And that's where that B complement will come into handy. And again, you may have not known that that's what you needed, but at this point we've used everything else, so that must be the thing that's going to help me figure it out. Now B complement is everything that's not in B. To show this, it'll just be easier if I shade the region. So basically everything that is not in B, it also includes the universe that's outside of any of our other three sets that we're concerned about. So it's all that. It's just not this circle that is B. So then what we can do is take our number 51, which is how many elements are in that yellow part, and we can subtract off all of the elements that are inside one of the regions. Oh, I'm doing that wrong. Hold on. That are inside the regions there that we don't want to include in our universal set that's outside of any of the regions. So in other words, when I'm trying to figure this out, I changed my highlighting there a little bit. I'm trying to figure out how much is in the yellow area. What I know is how much is not in B. So that's going to be all the yellow and green areas. So I need to subtract off the cardinalities of the green area. In other words, to figure out how much is outside of A, B, and C, I need to take 51 minus 15 minus 6 minus 18. Doing the math on that gives me a 12. So that gives all the regions there. I hope this breakdown helps. Let me know if you have any questions about it.